Hello, everyone. My name is Ryan Conley. I'm a staff solutions consultant with VMware. Tonight, we have a very special guest. We're going to talk about what has become a very niche use case, which is developing Mac iOS apps on Mac hardware. And a key way to do that efficiently and economically is to virtualize it. This session stemmed with Stefan and myself. I've been working with VMware customers for over 4 years, and we've determined that there's a lot of tribal knowledge in this community. There's a lot of people doing this on their own. There's a lot of people working with Mac Stadium to do this in large-scale hosted environments. And there's different ways to do it. There's different benefits and different ways of doing it. And Stefan and I were working with a customer earlier this spring. And we were working with a customer who had challenges going with how do I streamline this? How do I make this more efficient in my CI/CD environment? And we walked away with a conversation of, hey, we should build a community around this. And so we started with Slack using the VMware code. And VMware Code has been very generous to host tonight. And so if you're on VMware Code, it's under the hashtag Mac on vSphere. If you're not, go to code.vmware.com. And that's where all of the code snippets, that's where the community events are, that's where you can kind of join the Slack channel. And so tonight we have the privilege of Stefan, who's flown in, and he's going to go into detail and share his experience with large-scale Mac deployments, how they're doing it most effectively and most efficiently.
So I'm going to mix the experience I have with, I will say, regular workloads in how to use it with particularly on Mac platform. So I'm going to mix in between. I'm working for all the globals customers for VMware. Globals means all the large financial, all the large pharmaceutical. They have like really interesting scales and really interesting problem. So I'm going to mix that with what is particular and really specific to running on Mac hardware. And this presentation is not meant to be just me talking. I want it to be interactive, and I count on everybody to just stop me and ask me a question or disagree with me. It's perfectly fine. I don't know the perfect truth. This is gathering of experience. Something is connected. So rapid presentation, who I am. I'm Stefan. I'm going to give you, grant you like not saying my last name, that's okay. I'm just Stefan, that's enough. I've been working with VMware for like 8 years, focusing on automation and building in between small and large scale clouds for private customers and service providers. Tiny service providers and pretty big service providers. I've been working for a lot of them. Been in France before, maybe everybody can say from my kind of slight accent. I'm French. So this is how I'm going to walk you through what is design. Pretty simple. We're going to start with design and what is the design challenges. Something really important to me. I've been running operation for a long time before joining VMware, so maintaining something you design is really important. Just designing in empty and not running it has no value. And then the integration is, yes, we've designed a magnificent solution. We know how to run it, but why do we do that? So on the design, sorry. Yes. The first thing is what do we want to create? So one-liner, it's not really a one-liner, as you can see, it's stretching on like 3 lines. I just want to have access to macOS instance, especially with Xcode and all my tools, and to build or test my favorite code. And if I can get that through an API, that would be pretty cool. That's a one-liner of what the design is going to be for. We call it also CI/CD, continuous integration, continuous development. We're going to automate completely the integration, the build of the code, and the testing of that code. What does that drive? Pretty simple. We have VM that are usually disposable. I get some customer running disposable VM. I get some customer running recycling VM. And we're going to see later in the design, why do you want to recycle a VM or why do you want to just dispose of VM? We have a point where we need to create a VM pretty fast. We don't want to wait like extended amount of time, so the VM creation needs to be pretty fast. The next phase is what I call registering the VM and making that VM usable must be fast also. It's not because I clone the macOS VM super fast that I'm happy. I need to be able to connect to that VM. I need to have the tools on that VM. It needs to be configured properly. I have access to my source control and so on and so on. All of that needs to be in place so I can automate completely the CI/CD pipeline. I managed to make that work. So first part of the design, I really sliced the design in the different cores of what is virtualization. We're going to go over storage, we're going to go over compute, and we're going to go over networking. No surprise in there. So on the storage, we have two options. Local storage, central storage. We kind of know the caveats and advantage of all of them. Local storage is super cheap, and especially on the Mac platform, we have pretty fast storage. So there's like a good feeling there. So like, maybe I could use local storage. The issue is going to be you may have some slower cloning time, and you will have heavy maintenance. Just imagine you have to copy to 200 nodes your macOS image. Anytime you update it, that's painful. Painful equals expensive in operation, equals error prone. I see my fellows from Mac Stadium laughing in the back. So that's why usually we use central storage. And this is true for any vSphere environment, not just for the Macs, but we have still like on the Mac something different. It's faster for clone. Yes, if you use accelerated storage that use VAI in vSphere, it's going to clone super fast your VM. Even a cheap Synology NAS is able to clone a Windows VM in 20 seconds, which is way faster than anything else, just because the disk array is doing the cloning and not the Esxi. It's easy for maintenance. All your images are in the same place. You want to update it. You update once for the cluster in that central storage, and here you go. You get the new image. The drawback, and this is really Mac particular or Mac specific, is you have to have extra ports maybe for that. Configuring extra storage may require fiber channel adapters or network adapters that are different from the one you're going to find in the basic Apple compute, if we can call it this way. So I would say like the tendency and my recommendation, and again, this is a global recommendation, you may have particular use case, is to go with central storage just for the ease of maintenance. Even though you can get cheap storage, it's PCI Express, it's really super fast. Using the local storage can bring some issues. And we also in the installation, the drivers you need to be on and everything and so on and so on. So on that storage side, I would say like, let's go with central storage. It might be the easiest way to do it. So hardware. So it should not be called hardware, but compute. But we're talking about one vendor, and exactly just one vendor is selling that. So yeah, the first one is a Mac Pro. Yes, we get good amount of memory, get a good amount of I/O options, get 2 network cards, which is a good start for a Mac. We get a large number of Thunderbolt 3 ports, so that's pretty good also. The main issue is that the Mac Pro is pretty old. So the CPUs are from like third quarter of 2013, and the design is more from 2011 than something else. So it's pretty old. And actually, if you look at VMware HCL, that's the only option you have. So you can run on Mac Pro, or you can run on Mac Pro, or you can run on Mac Pro, or you can tinker. So you go out of what is supported by VMware. It's working, it's just not supported. You can go with the Mac Minis. So the Mac Minis is super cheap. You can build what I call a RAIM. It's a redundant array of inexpensive minis. It's like the equivalent of Mac Minis of the RAID disk array. So you can get really like a load of them for a reasonable amount of money. The drawback, less I/O option, and that's really like really less. So you get 1 network port, that's it. And you get, I think it's 1 Thunderbolt port, and that's it. So it's really limited on that side. Which drives to limited bandwidth. Yes, you're not going to be able to drive that much I/O from there. So yeah, Mac Mini, yeah, why not? Then you get the iMac Pro, which is brilliant, because you get faster and recent CPU. Then you get no net boot because of the T2 chip. So thanks to Ryan for that. It's bulky to install. Even though I know some people that are pretty good at installing iMac Pro in the data center. And last but not least, yeah, Esxi just doesn't run on it. And that's the only option you have. So I would say like the recommendation here is pretty simple. Go with a Mac Pro, not by choice or not by anything else. It's the only one that is supported. This is where you're going to find the most experience from the different vendors, from Apple, from VMware. Well, not really from Apple. You're going to find a lot of experience from VMware on it. So that's the way to go. Even though it might be difficult to provision sometime and buy in large quantities. Networking, that's an interesting part. So we've seen that the only option we have is a Mac Pro. Mac Pro comes with 2 GB Ethernet interface. So if you do some benchmark and you look at it, with 2 GB interface, you can run, if you put everything through those 2 GB Ethernet interface, you can run 2-3 VM per host if there's not that much clone traffic because you have an accelerated disk array. You can cross what we call a cross failover the links. So one link is going to do the VM traffic and the management. Not going to use that much management traffic, so that's pretty good bandwidth for the VMs. And one link for the disk access. That's still only 1 GB, and it's going to limit big time the number of VM you can drop in that. The other options is go for expansions using Thunderbolt 3 to PCI Express. The vendor for that is Sonnet. I looked on the internet. There's not really a lot of other vendors. Now that the eGPU is supported by Apple, some vendors are building some boxes in which you can put some PCI Express card, but they're not really certified, supported, and whatever. It's not as comfortable as the Sonnet product line on that side. Especially they come with like ways to rack in the standard data center rack the Mac Pros with power supplies that are proper with like a number of PCI Express slots that are legit. It's really like the only option you have if you want to go more than what is out of the box. Again, if we go back there, I think the pros are using the Sonnet extension. I'm looking at my fellows from Maxadium. From the pictures I've seen and the VMware session, it looks like you also like what they're doing.
Also the 2 vendors.
Yeah, that's it. So logical design, now we're going to switch to what is the logical design on vCenter, vSphere, Esxi, and so. vCenter is super simple. I'm going to follow VMware recommendation there. Just use the vCenter appliance. Don't try to deploy it on Windows. And scale it horizontally. If you want to access and do a lot of operation at the same time, you may want to have more vCenters than reasonable. Meaning, the vCenter maximum number of VM is 10,000 VM, 1,000 or 2,000 hosts, something like that. You're going to want to stop way before that, having like maybe 1 cluster, 1 vCenter, so you can maximum the throughput of API calls you can place to a single vCenter. And that's not only true for the Mac Pros. This design is true for also, if you do it on any other platform, it's going to be the same issue. You want to have multiple vCenter just for the ability to place more and more calls to it. So yeah, stop way before the 10,000 VM. Same thing, each vCenter must be local to a data center. Don't try to have a vCenter that's going to manage 2 different data centers. First of all, on the resiliency side, it's not really easy. If you lose a data center in which you have the vCenter, you cannot manage the Esxi host on the other data center, which puts you in an uncomfortable situation. So that's why I will recommend the vCenter to be local to a data center. Then on the cluster design, everybody says, I'm doing CI/CD, I want maximum performances, I don't want my VM to live for a long time, so running DRS is useless. I totally agree with that, except that you may want to still have DRS enabled on manual, so if DRS is not going to move the VM for you, don't worry, no like load balancing of the VM doing compilation jobs. But if DRS is still activated, you can go maintenance on one node, which might be interesting if you know it's going to fail. We're going to talk about it's going to fail a little bit later. It's pretty hard to know actually. HA, I would say the use of HA depends on your orchestration layer. So if in your CI/CD pipeline it is heavy to recover from losing a node that is doing something, you may want to enable HA if it takes you a lot of time to recover from one node failing. If your CI/CD pipeline is really atomic and can withstand the loss of one node and just replace the job on another surviving node, don't enable HA. Keep it super simple on that side. It really depends. You have to know what you're doing with the cluster to know if you need HA or not. Cluster size. This one is pretty easy. The bigger, the better. So maximum number of hosts is 64. Why the bigger is the better? It's just because it's less objects to manage from your orchestration layer. You have a pipeline that is defined to use a cluster as its compute source. If that cluster is big, you can have like only one cluster as a compute source. If that cluster is small and you have multiple clusters, you will have to code inside your orchestration layer to switch between the different clusters and so on and so on. So just make it the bigger, the better, especially if we're not running DRS and we're not running HA. It's just like a grouping of resources against which you can place API calls. It's just make your life easier. The capacity, that's also an interesting question. What is the capacity of one of those clusters? If we don't run DRS, we don't run HA, and we want kind of a one-to-one mapping between the physical resources and the VMs, because those VMs are going to run for a short amount of time. The only thing I want from them, if I'm doing build, is to build the fastest they can. So that's a one-to-one mapping. If you're doing testing, maybe not a one-to-one mapping. You may want to have more VMs because testing doesn't consume that much resources as building a software. So you're going to have to find a sweet spot there. I would recommend to define it from the front. We're going to see it a little bit later in the slides, just by doing benchmarking. Every kind of application is going to be different. A little bit better on compiling, a little bit better on testing. This is something you can just test, and if you have a tool to manage your CI/CD pipeline, you're going to get metrics from them, and from the metrics, you know if I'm better with small VMs, overloaded, one-to-one. You just have to experiment to fill those numbers. It's going to be different per workload, so there's no universal answer there. The only universal answer we can give is, I will say, the usual guidelines. Production workloads, 4 vCPU per cores, it's not too bad. Dev, VDI, yeah, you can go 8, 10, even more. But that's the only guidelines we have. It really depends on your environment, and for that we will see later that having some kind of reporting framework, some monitoring tools, I'm going to put my VMware ad again on, like VROps, is going to be brilliant for that. Again, with VROps, you're going to have some challenge with a CI/CD environment. Workloads that are ephemeral, so you cannot like just take a VM and say, give me what is this VM consuming, because the VM is just going to be gone before VROps even collects enough metrics on it. So you're going to have to read the metrics at the level of the cluster or at the level of the host. Host is okay. Again, we don't use DRS, so VM are not moving around, so yeah, using the host as a baseline for your metric is good. Density and performance, I already covered a little bit of that. I'm going to start by the end, sorry. When you build that and you want to do one-for-one, always remind that Esxi does not come for free. It does consume resources as an overhead. Even in the high-performance environment I designed for customer, I always say, that's a rule of thumb. It may be less, maybe a little bit more. I will say 1 core and in between 2 and 4 gigs of RAM are not available for the VM. Just keep it aside, because if you don't keep that aside, you're going to feel that maybe it's going slowly, or you get like slowing down on the VM just because of the Esxi. It needs resources to work. So, like, again, testing and benchmarking are key. I talk with customers with one massive VM using the entire Mac Pro. They say, yeah, it's the best way to compile the fastest I can, and so on and so on. Then I get customers say, I want to stuff the maximum number of VM I can on the Mac Pro because it's expensive, I want to use it to the max. Again, on that side, like, please test and benchmark your applications. get a baseline of how it's performing, and then you get the numbers and where you want to go. As a general manner, smaller VMs tends to perform way better than bigger VMs. I got even an old benchmark I've made for a real application for a real customer. I was not even at VMware at that point. I was a customer. It was super simple. We had like one massive machine with at that time it was massive. 4 vCPUs and 8 gigs of RAM. Yeah, I know, it's small. But at that time it was massive. Running Apache. So we benchmark how many connections and how fast I can get the content of that Apache. And then the enterprise architect, and it was funny because it was not me at that time, came and said, but Apache is like, it's a web server. It scales horizontally. It doesn't scale in, it scales out. So let's build like 4 machines with each of them, one vCPU, 2 gigs of RAM. Actually, we achieve 1.5 times more throughput with 4 VMs than with one massive VMs. So yeah, some workloads perform way better on small, and the root of that is pretty simple. Just imagine an hourglass. You have small grains of sand in the hourglass and big ones. The small ones are going to be the first one to pass through. Big ones are going to take some time. Small grains is 1 vCPU machine. Big grain is like 2 vCPU, 3 vCPUs, and more machines. Exactly the same thing with CPU. You have more opportunities to schedule to CPU a single vCPU request than a big multi-core machine. Even if we have relaxed co-scheduling, it still requires to have like kind of a sync in between the cores. You cannot like say, I'm going to schedule 1 core and the other one is going to come in 20 seconds. That's okay. DOS is not going to like it. It's not going to work properly. Single machines tend to perform better. So on the density, like really my recommendation there is like know your profile, because depending on what you're doing, you may want different density. You may even end up with having one farm which is dedicated to building and one farm which is dedicated to testing with different metrics. The building farm, you're going to go 1-to-1, 2-3 machines per Mac Pro. The testing farm, maybe you're going to go 120, 130. How far you want to go depends on Mac OS. Less than 4 gigs of RAM is not going to work perfectly. So I say 1-to-20 is a good number. And hopefully I'm not going to get like comments from the people that actually know how good it goes. Maintain, the most painful part. I got a boss a long time ago told me, when you buy something, it's going to cost you 100 to buy it. To run it, it's going to cost you 100 every year. And that's if you're doing a good design. So the CAPEX equals, the OPEX equals per year equals the CAPEX. So that can be really expensive, especially when you're talking about large-scale Mac Pro farms. Those machines are pretty expensive even compared to like standard servers. So yeah, Mac hardware does not come with any kind of remote access. So you may want to have remote power control. Like I can remotely power on, power off the beast just by cutting the power and putting the power back on. You may even want to go with a remote KVM. Remember, a long time ago, we had those kind of hardware. Allows you to connect remotely to the physical keyboard and mouse of a lot of computers in a single rack. And we had all the crazy cabling that was going with it. It was terrible. But there might be some of the options you want to go through. I won't go with the remote KVM right away because you can, if you net boot the machine, you can manage it without having access to the physical console. Except maybe take a screenshot of a purple screen of death or something like that, but no more than that. So back to how to deploy it. Yeah, netboot is the easiest way to get anything on the Mac, except if you have someone in charge of dropping a master on there and then putting the Mac Pro in the data center. Netboot is pretty cool. Netboot comes, the way to say it in vSphere is auto-deploy plus the host profiles. Allows you to stream directly the image to the Mac Pro and run it from there. Multiple advantage. The first one is patching. As patching is just put a new image in auto-deploy, reboot the Mac, that's it, it's patched. You want to go from 6.0 to 6.7, same thing, you just reboot the machine and that's it, job done. It's going to come with the same host profiles, it's going to be configured exactly the same way, go in the same cluster and so on and so on. 2 flavors of auto-deploy. I would say the purest one, which is stateless. We don't even store anything on the Mac. We just boot from network, gets its config from the network, and that's it. We have an option to have a local cache in case your auto-deploy server is down. The Mac is still going to boot with a local image. That's the purest way to use auto-deploy. We have another way to use auto-deploy, which is interesting in some situation, which is I'm going to do a stateful install. It's just an option. In the host profile, when you use auto-deploy, say, I want stateful installation on the hard drive. First time the Mac Pro is going to boot, it's going to boot from the network, get the image. Image is going to be written on disk with the config from the host profile. And that's it. You install the Esxi on the machine without going there with a CD, ISO, or whatever. So that's another way to use it. Another bonus of stateless auto-deploy, I think, is the fact it doesn't use local storage. We've seen some issue with local storage that didn't work properly. If you use auto-deploy, you can even rip off the drivers for the local storage. You can rip off any drivers you want from the image. You can make the Esxi image like as small as 60 megs. You're not going to get a lot of drivers for 60 megs, don't get me wrong. But you can remove all the drivers that cause you trouble. You don't want the onboard NICs because the onboard NICs doesn't work properly. Just don't put the driver. You remove the problem. You don't want the local storage. Don't put the driver for ATA storage, and that's it. PCI Express is more complicated, but what? So that's another bonus of auto-deploy. I'm going to quickly pause here and ask anyone from Mac Stadium, I'm seeing in the back of the room, did you try auto-deploy and do you have any issues with it? Because you're the one with the most experience. yeah, I love that short answer. Yes.
So I kind of got it running at home on a Mini.
Yeah.
Using, I kind of got it running at home on a Mini using Williams walkthrough.
Yeah.
I tried it in the data center and we couldn't get it running. So after blessing, like, okay, whatever server was going to be used for NetBoot on the test Mac Pro,
yeah,
it would never
actually started.
Yeah, it would never pick it up. I mean, I got simple kickstarts running, but I've never been able to actually get it to boot Esxi off of NetBoot.
Okay. So that means that this part needs some more investigation. We're going to see on the last slide what we're trying as a community to do there. But stateless is something I'm using at very large scale with some customers on Intel hardware, like basic white boxes and whatever. I know it's more complicated on the Mac because it's just like we don't know how it's running. Only one people know how it's running and doesn't want to talk. So yeah, we can investigate on that part.
Because I know I've seen that people have gotten it working, but I'm not really sure. Well, depending, is it like missing something in a DHCP option, or was it something specific to it never actually taking the bless hardware? So you can look from terminal when you boot it in recovery mode and see, okay, well, these servers it should accept from iPixie in NetBoot. So.
Yeah. Okay, so we should investigate that part because. Using stateless and auto-deploy on those kinds of farms really makes a big advantage, I think. Yeah. And basic things like changing the allocate. So you can attach a profile to a host based on the MAC address or the serial number. Imagine a cluster, one of your Mac Pros goes down because it's broken or something. You just put a new one there, change the attachment of the profile to another MAC address, and that's it. You're good to go. Yeah. Which at that point is brilliant because you just replace pretty fast a Mac Pro in your farm without having to do all the configuration if you're using SAN, which is going to be the masking, the zoning, and whatever, and things like that. So it really gives good advantage. Something really interesting for me, and my large-scale customer is using it for that, is the pace at which you can patch it. You don't even have update manager. You don't have to go through downloading the patch to the machine, installing the patch, rebooting the machine, whatever. Just reboot the machine, it's going to get a new image from the repository, and that's it. Makes your life way easier on that side. Fixing an issue also is way faster. You just push a new image, reboot the farm, and you fix the issue. Maintain. Next part of maintain is monitoring that. Monitoring of the Mac hardware. Yeah, it just doesn't work. So Esxi has everything embedded in it to use the industry standard monitoring of the hardware. So if you deploy it on their hardware, you're going to see the basic. Speed of the fan, temperature of the CPU, and so on and so on. On a Mac, you're just going to see, hey, it's a Mac. And that's it. You don't know if one of the DIMMs is in predictive failure or something like that. So at that point, the only thing you can do is like, okay, if one of them fails, meaning it stops responding, maybe it's broken. So if maybe it's broken, I will say just pull it out of the pool, put it in maintenance mode, and repair it. That's the only way we have. And that's purely on the hardware monitoring. We're like pretty blind on that side. We don't have that much. For the rest of what is monitoring, capacity being pretty fine, as you've run your benchmark before. Capacity planning is pretty easy. You know how many VM you can run, you know how many you need. You know if you need more, if you need to go faster, you just buy the equivalent amount of hardware to match your requirements. The performance is one challenger. We have a high churn environment, so the VM are going to disappear because it's just dropped in once that job is finished. So you cannot in VROps follow like a VM lifecycle. So okay, that VM has been performing that well for the last 6 months because the VM only lived like 2 hours. So we will have to fall back on collecting the metrics at the cluster or the host level. I will say if you didn't enable DRS, host level is good enough. If you have the same density and your orchestration is always putting, I don't know, I'm going to give a random number, 5 VM on each host. Take any of those hosts, see how much it performs. And at that point, you can know, okay, maybe I'm too aggressive on the VM, or it cannot deliver the performance, or maybe I'm like too loose because I never have a good enough demand on that host. So maybe I can put some more VMs. Something I will also do is cross-reference with the metrics you get from your pipeline in your CI/CD tool. An easy way to do that, you can use VROps API to inject actually the metrics you're collecting from your pipeline directly in VROps, and then you can correlate the performances of your hardware in the backend and the execution time of your pipelines. That's a good way to do it. You can also do it the other way. You can use VROps API to extract the numbers from VROps and drop them into what is your favorite number mashing tool. I would say VROps on number mashing is pretty cool. So yeah, I will like drop them in VROps for that. Then integrate. So we have a wonderful machine we just designed. We just need to like drive that machine. On a particular CI/CD use case, the environment is going to be pretty much headless. So nobody is going to connect to vCenter to do any action except fixing ESXi host. Attaching storage, deploying new, but that's it. The rest of it is going to be purely driven by API, by the orchestration tools. A good one, everybody loves him, Jenkins, just because he looks good. Maybe other things. It's going to drive to the vSphere API. Usually, you will define at that level how many VM you're going to stuff by cluster and so on and so on. And you can, in your script or your automation, build the logic to populate the VM, deploy the VM, shut down the VM, and so on, and destroy, not even shut down the VM and destroy, and so on. If you reach a certain level, I would say if you have more than, there's no universal level, but let's say about at 5, 10 vCenters manage at the same level, you may want to put a CMP on top of that. Just because managing all the endpoints inside your code is going to be painful. You're going to have to manage across vCenter capacity planning or where I can stuff VM. You're going to have to manage where I'm going to deploy those VM, how do I choose a vCenter, and so on and so on. The advantage of a CMP is going to abstract completely that part. It's going to say, okay, give me a machine, and the CMP is going to take care of provisioning that machine wherever it has the space to provision that machine and whatever quality of machine you ask. Give me a testing machine, give me a build machine, CMP is going to take care of that. Of course, I'm from VMware, so the example I've given is VIO, which is VMware Integrated OpenStack, VRA, a little bit maybe too much on that side. It's going to be too much governance for this kind of use case. vCloud Director is like really good at being bashed by API. And then you can imagine also using the new VMware Cloud Automation Services for that. which is even easier. You don't have to deploy it. It's SaaS. It's magic. Orchestration tools you can use. Yes, on the scripting side, choose your weapon. Power CLI is a very good one. Very large community, easy to use. Python, if you want to drive it from Jenkins, maybe using Python is going to be easier than Power CLI. Perl, that's for the old school. We have the Perl SDK and everything, but Perl, it just does the job. It works. And this is usually, I will recommend those for any that is a one-off. You want to script a big change, and this is something you're only going to use once. Or there's going to be something that is user-driven. It's a script someone is going to run, like a human being is going to take care of that. Anytime you want to do something that is more like orchestration, VRO for vSphere is super easy to use because you don't have to learn the vSphere API. VRO is going to maintain that for you. Also going to maintain the connections, the service account, and so on for you. That's perfect. You can schedule the job. You can integrate with like different systems. If you don't want to use VRO, you can use different type of orchestrators. Not making any advertisement, but like I know VRO a lot because I've used it for a large number of customers. And it's pretty good on vSphere, actually, which is not surprising because it's from VMware. Isn't it? So next step. So now we're like at the beginning of a new era. Finally, all meet together to talk about that. I think the next thing we need to do is grow the community, have more and more people talking about it, integrate the best practices we can get from everybody. As you were saying, it was tribal knowledge inside VMware. We have people left and right that knows to run it because they like it, because they have the customers for it. We need to go more on that side and have something that is more formal. When I say formal, it's not going to be anything painful. It's just like I want the community to exchange and to work on that. And for that, we have the Slack channel on VMware Code, hashtag Mac on vSphere. Just register to VMware Code. You get access to the Slack channel, and from there, there's a community there. And the next step, that's more a takeaway, I will say, for Ryan and me, is to try to write and publish a reference architecture. Something we can say, okay, if you want to do it, this is how you should do it. We tried it at different places. At that point, I will say, if we can try it and at Mac Stadium and at VMware Engineering, it will be perfect. We'll have something that is really stamped. We know it's working at scale. We know how to do it, and this is how you configure it. That will be something that's brilliant. To publish the reference architecture, like in my dreams, I want to work with Apple. If they want to work with me. They're not always super open on that side. I will be super happy. And when I say relevant partners, on the hardware side, like clearly Sonnet is going to be part of them. Because this is what this is what everybody's using. So I think that's some of the partners. And on that, getting sure it's actually running like in real life and at scale, like the most relevant partner here is going to be Mac Stadium. Because because who you are. That's it. Any question? Nobody stopped me during the presentation. I'm like super disappointed.
I have a Facebook question.
Yes.
We had quite a few people watching on Facebook. I had a question that said, would a Mac Mini i5 CPU or i7 mobile CPU outperform a 12-core 2009 to 2012 Mac Pro?
Yes and no. Depends what you're doing on it. In pure performance, it's not going to be as good at multi-threading and such. Especially the bandwidth to memory is limited, and we know all those limitations. But I will say in a use case where you're doing just a test and not maybe a build, it might be easier on the Mac Mini, even though it's unsupported. Sorry.
For that centralized storage, run couple of VM per Mac Mini. Do you using iSCSI, Ethernet, or what kind of the network you're using, or fiber channel?
So a big discussion is, it's funny, it's a question I'm asking when I'm interviewing people coming in PSO at VMware, is what is the best protocol? My answer is the protocol the customer prefers and is the most comfortable with. Acceleration is easier to obtain on iSCSI and Fiber Channel because it's log-based, so anything that is going to be what we call VAAI, it's going to be write the same or write zeros or so on, which is going to help you cloning faster. It's going to be like out of the box on iSCSI and Fiber Channel. If you try to use NFS, NFS is brilliant because it's super simple, but VAAI on NFS exists. It does require the addition of a software. It's not as easy. On a Mac Mini, I will go Ethernet. I don't have that much option to extend a Mac Mini. There's only one Thunderbolt. So I will focus on getting two 10 gigi maybe in there, or 2 gigabyte, proper gigabyte in there, and do everything over Ethernet.
So you recommend 10 gig is a necessary. 10 gig is a necessity instead of 1 gig.
So
you recommend?
The out of the box on the Mac Mini is going to be a 1 gig. On a single 1 gig, you're going to be really limited on what you can do. If you put an enclosure behind with the Thunderbolt, you can get 2 10 gigs, which I think is the sweet spot in between, like not going. If you put more cards, you're going to make your Mac Mini as expensive as a Mac Pro. At that point, you say, okay, I spent enough money to justify buying a Mac Pro, so stop. It's an economic decision at that point. And I think going full Ethernet is the future. I don't have, but that's more like a personal judgment. I see Ethernet being everything pretty soon, and Fiber Channel being like going away. Just one connection is enough. It's fast enough. It's even like.
I think it really comes down to the resources that you have available.
Yeah.
We've done experimentation with both Fiber Channel and iSCSI in the past. It really comes down to your network architecture that's supporting it. If you've got the architecture to support Fiber Channel and a dual fabric and do it properly, Fiber Channel can be extremely scalable in the sense that it's very reliable and that you've got very consistent performance.
Yep.
But Fiber Channel can become cumbersome from a management perspective if your environment changes a lot. iSCSI, if you've got a network that's built for equal cost multipathing and you're really leveraging that properly, you can get equal or better performance from iSCSI with modern Ethernet implementations.
Yeah. And also depends of some of the workload just because of the size of the frames you can throw on Fiber Channel and Ethernet. Ethernet, even with the giga, mega jumbo frames, you're never going to like throw as much as you throw in a Fiber Channel packet. Fiber Channel packet, you get the guarantee that it's going to be delivered. There's no doubt it's going to come there. Ethernet, yeah, it may come one day.
I think, so I'm really interested in NVMe over Fabrics and Rocky V3. So Rocky with TCP to really close that gap.
Yeah. But like we're talking about something where like we're chasing the last % of performances. Usually I say more like, okay, that will do the trick for 95% of the customers. I know some customers that will chase that 1%, and this is where they should go, there's no doubt. If you're 95% of the population, you may be good with an old-fashioned Ethernet. Does the trick for you.
First, I just want to say, Stefan, Ron, thanks for putting this together. I think it's great to get a group of people, albeit small, in a room to talk about VMware on Mac, right? Because there's this thing everybody's trying to do and nobody's doing it correctly, and everybody constantly has questions on how to do it right or better.
Yeah.
So thank you. Number two, one of the things that I'm curious about, if you've come into in conversations with customers, is support for APFS on ESXi.
Yeah, but I got no information on that, I'm sorry. And even if I had information, I may not be allowed to share them. So Ryan, do you have more than I can share?
My understanding is we now have APFS. Am I correct? I thought there was a recent update as of last summer with 6.7. We finally have support. I had several customers waiting on that release. They themselves needed to test their software on APFS, we as a company were waiting on Apple to GA it. Once they GA'd it, we could start testing it. But we do have support now.
Yeah.
So I work. I think for a centralized storage, it all depends on what kind of storage you already have. So you can tap into that kind of resource instead to build new infrastructure for iSCSI. If you already have fiber channel. So for fiber channel, if you have Thunderbolt, what kind of adapter from Thunderbolt to Esxi do you recommend, or what do you use? I have been working with ATTO, but what's your recommend? And I also brought a ATTO drive to be certified by VMware. So in your lab, what kind of do you use?
So actually, there is no direct adapters. Usually you use Pci Express Enclosure, and then you throw in there the cards you want. If you follow what is on, I think it's a slide before or something, end of the slide, sorry. What Sonnet says, Sonnet sell their own cards to put in there, which are the only one to be certified by Sonnet himself to run inside their enclosure. I faced with one customer issues with that because those cards are clearly mainstream market cards, just with a Sonnet firmware in there. Maybe not a firmware, just like a tagged state Sonnet. It's not like Intel. Meaning you cannot drop in there the firmware upgrade you need. So you can have a dual 10 gigi. That is actually an Intel one. That has been rebadged as Sonnet. We find issue finding an update to the driver, and they have network port going down just because it's a known issue on that Intel machine, but we cannot patch it because it's not really an Intel, and we cannot really put an out-of-the-box Intel in there because it's not really supported by Sonnet neither. So I think that's maybe where we need to work with them, just to say, okay, maybe certified enterprise-grade HBAs, enterprise-grade NICs that are from Intel, Brocade, and so on, so we can just use the usual firmware update and so on it, and keep the compatibility with the XXI.
And I can kind of share we definitely have had some customer scenarios where they are using Sonnet cards. They're doing Thunderbolt to 10 gig, for example. And a challenge they've faced from a driver standpoint is Sonnet is coming to the market with a solution, but sometimes that driver, for example, is coming from a Linux driver. It's not specific to ESXi, and that has led to some challenges in terms of troubleshooting some performance or reliability issues.
VMware certifies certain manufacturer, just like one that Addo, I've been working with for a year, so their driver gets certified by VMware. So I'd like to know what kind of do you use, or you have recommendation list for that kind of adapter.
So on the adapter, you're going to base your decision. So in the certification list, you don't have just network cards. You also have network chipset that are certified. So base your decision on what is the best certified chipset that is inside the card that has a name nobody knows at VMware. It's the best guess. That's why if we can get access to so from Sonnet you can get two things. You can get just a basic adapter that's going to give you two 10 gigi on one side and one Thunderbolt on the other side. This one is completely a black box. You don't know what's inside. It's kind of an Intel hidden somewhere in there, or maybe a VIA chip, or you don't know, but it's working. Then you have the PCI Express Enclosure, which gives you more flexibility because it just gives you PCI Express slots in which you can put whatever you want that is certified by Sonnet. This one is a little bit more flexible, a little bit less black box, because you can take that card, put that on, I don't know, an Intel server, random one, and update the firmware from there. But again, you are with a Sonnet adapter and not really with an Intel original one or Brocade or whatever it was before it got the crazy firmware in there. So I think at that point we may want to close up the gap in between Sonnet and VMware, so we can talk together and say, okay, give me your drivers, and we can certify firmware levels, and we're good to go.
And I would plug our Slack channel at that point. So as Stefan mentioned earlier, so code.vmware.com is where you could sign up for Slack. I know there's a couple of Mac Slack channels. Mac Stadium's already shared some with myself. On the VMware Code Slack, once you're there, just join #Mac on vSphere.
Yeah.
We're trying to close the gap in community, work together with vendors such as Mac Stadium, as well as VMware customers. So appreciate your questions.
And we're going to try to get also people from VMware, more than just the two of us. And we have the usual suspects. So yes, William is also on that channel. But we're going to try to get some more people that actually are knowledgeable on that.
And if you guys do want to join the Slack channel, if you just check the box at the very end when you signed in, I'll add you tomorrow. So you don't need to even do anything. I'll just automatically add you to the Slack.
It's like the best automation.
So, yeah. Just check a box.
Any more questions? You have? Nope. Thank you very much, everybody, for coming.